Now that we explore how lenses shape light, let's talk about another crucial element of optical systems, the aperture. The aperture is the opening that controls how much light enters a lens or optical system. It acts like the pupil of your eye, widening or narrowing to adjust light intake. So let's see a diagram which represents an aperture stop. Is a physical component that limits the size of the opening. Let's place also another optical element, a converging lens, already known for as optical component. And here we represent converging lens by this double-sided pointy arrow, which is only simplified manner to represent a converging lens. So let's place an object at some finite distance from our optical system. And let's see how the placing of this object will form an image. So as you saw previously, placing this object at some finite distance from the optical system will form an image on the right side from the lens, which will be downscaled and it will be directed downwards. Let's right now shoot an ray going from the bottom of the object until it meets the first obstacle in our optical system. So the first obstacle in our system, which limits this optical system light gathering ability, is our aperture stop. So as you can see here, we shoot this blue ray until it meets the first obstacle of our optical system. This first obstacle is called aperture stop. And therefore, we make an angle alpha from optical axis to this first ray, and we define a numerical aperture, which is a measure of light gathering ability of the optical system. We define numerical aperture as refractive index of the medium times the sinus of angle alpha. So a large numerical aperture means that the system can gather more light. A larger aperture, and this larger numerical aperture, allows more light to enter, which is beneficial in low light conditions. The numerical aperture is directly linked to the resolution of optical system. A higher numerical aperture generally corresponds to a higher resolution limit, meaning the system can distinguish finer details. Aperture also affects the depth of field, the range of distances in focus. A smaller aperture gives a greater depth of field. So you can meet numerical aperture in any optical systems, but numerical aperture settings are essential in cameras to control exposure and depth of field. The numerical aperture of microscope objectives determine the resolving power, which is crucial for observing these specimens. Telescopes with larger apertures can gather more light, allowing them to see fainter objects and reveal more detail.